Section 6.3 Inverse Trigonometric Functions. In this section, you will understand and use the inverse sine, cosine, and tangent functions. Find the exact value of the expressions involving the inverse sine, cosine, and tangent functions. Use a calculator to evaluate the inverse trigonometric functions for non-standard angles, and also find the exact values of composition with the inverse trig functions. Going back and forth between trig functions and their inverses, let's recall the two functions are inverses if and only if f of g of x is equal to x. Remember this? Also, f of the inverse of x is also equal to x. Also, that means that the domain of f becomes the range of the inverse function. So let's recall that from a trig function, the domain, remember from a unit circle, the domain, the x values are the angles, that is from negative infinity to positive infinity. And the range is, since you have the unit circle here, that is from negative 1 to positive 1. And now for the inverse function, it's like switching x and y. So the domain is now from negative 1 to positive 1. And the range is the angles. Now let's practice evaluating trig functions and their inverses. The first one, sine of pi over 6. So remember, if you have the unit circle, this is pi over 6 with the coordinates square root of 3 over 2 and 1/2. And remember, this is sine, so sine of pi over 6 is, yes, 1/2. Then inverse sine of 1/2 is pi over 6. How about cosine of pi? So this is pi, and pi, we have here negative 1, 0. So cosine of pi, this is the x coordinate is cosine, and that is negative 1. Then inverse cosine of negative 1 is equal to pi. So hopefully you're seeing why it's so important that we know the unit circle well. So restricting the domain, why do all graphs of invertible functions have in common? Yes, it is 1-to-1. So since trig functions don't have that, we will have to restrict their domains. So the inverse function y equals inverse of sine means x is equal to sine y. The inverse sine function is sometimes called the arcsine function and notated by arcsine of x. So the inverse sine function of x has a domain of, yes, from negative 1 to positive 1, and the range of from negative pi over 2 to pi over 2. Then the inverse cosine function of y of x means x is equal to cosine of y, and the inverse cosine function is sometimes called the arccosine function, notated by arccosine of x. And the inverse cosine of x has a domain of, again, from -1 to 1 and the range of from 0 to pi. Then the inverse function y equals inverse tangent of x means x is equal to tangent of y, and the inverse tangent function is sometimes called the arctangent of function, annotated arctan of x, and it has a domain from -infinity to +infinity and a range of from -pi/2 to pi/2. Finding exact values of trig and inverse trig functions. We'll not only want to look at the graphs of these functions but also evaluate their inputs. So let's practice. Example number 2, evaluate each of the following. Letter A, inverse sine of 1/2. So if we have a unit circle, let's say I have a unit circle here, 1/2 is, again, we used this earlier, pi/6. We have here square root of 3/2 and 1/2, and we know that this is sine. So we could say that also you can rewrite this as solving for the theta, the angle is equal to inverse sine of 1/2, which is equal to pi/6. And we know that range of inverse sine of x is from, remember, -pi/2 to pi/2. That means in a unit circle, that is from quadrants 1 and 2, 1 and 4. So from negative, this is pi/2 and this is -pi/2. So that's why quadrant 1 and quadrant 4. So we have here letter A, theta is equal to pi/6. Letter B, inverse sine of negative square root of 2/2, where square root of 2/2 that is this part here, whereas you have here square root of 2/2 and negative square root of 2/2. So this is your sine, and what is this? That is 7 pi/4. But 7 pi/4 is not in the interval of -pi/2 to pi/2. So all you have to do is just get the coterminal of 7 pi/4, and that is, we need a negative angle coterminal with 7 pi/4, and that is going to be -pi/4. Okay, then letter C, inverse cosine of negative square root of 3/2. We are looking for an angle in the interval, this is cosine, from 0 to pi, with a cosine value of negative square root of 3/2. And that is an angle which is equal to this angle here, 5 pi/6. So the coordinates here are negative square root of 3/2 and 1/2. So the cosine is negative square root of 3 over 2. So that is within 0 and pi. So this is, the answer is 5 pi over 6. And for tangent, inverse tangent of 1, we're looking for an angle in the interval negative pi over 2 to pi over 2 with a tangent value of 1. And the correct angle is, so again, if I have a unit circle here, oops, to get positive 1, from negative pi over 2 to pi over 2. So here is pi over 4, and the coordinates of pi over 4 are square root of 2 over 2 and square root of 2 over 2, and tangent of that is equal to 1. So for inverse tangent of 1, that is equal to pi over 4. Okay, let's try more examples here. Quick check. Number 1, evaluate each of the following. Inverse sine of negative 1, the unit circle, negative 1 is here, this is 0, negative 1, and this is 3 pi over 2. So we have theta is equal to 3 pi over 2, but we know that for sine we want from negative pi over 2 to pi over 2. So we just need to get the coterminal of 3 pi over 2, and that is negative pi over 2. For tangent, letter B, inverse tangent of negative 1. And for inverse tangent, this is from negative pi over 2 to pi over 2 and negative 1. So for us to have a negative, so this one, the coordinates here, square root of 2 over 2 and negative square root of 2 over 2, and if we divide it 2, it's going to be negative 1. And what is this angle? That is 7 pi over 4, but it's from negative pi over 2 to pi over 2. So we just have to get the coterminal of that, which is negative pi over 4. Then letter C, inverse cosine of negative 1. That is from 0 to pi, and where is negative 1? Here, this is negative 1, 0. So cosine here, which is equal to pi. So that is the answer for letter C. And D, inverse cosine of 1/2 in a unit circle, cosine again from 0 to pi. That is quadrants 1 and 2. So 1/2 cosine is this point, this angle, which is pi over 3. We have here 1/2 and a square root of 3 over 2. So the answer is pi over 3, yes. Okay. Next, using a calculator to evaluate. When an angle or the trig ratio is non-standard, we'll have to use a calculator to evaluate. Let's say, for example, here, evaluate inverse sine of 0.97 in both degrees and radians. And the easiest way to do this is with decimals. All we have to do is type inverse sine of 0.97, and I'll show it to you. Go to decimals.com and then type inverse sine. Click on the keyboard and click on functions, and you will see here inverse sine. So inverse sine of 0.97, and you'll see a number here, and you can check if it's in degrees or radians. Click on the graph settings on the top right here, and below you will see in radians and in degrees. So if you click degrees, so inverse sine of 0.97 is 75.93 degrees, and in radians, just click on it, is 1.325 radians. Easy, right? So again, use decimals, just type and then click on the graph settings and then just hit radians or in degrees if you want to convert in radians or in degrees. Okay, let's go back to our notes, and this is what we got. When we use decimals, the degrees is inverse sine of 0.97 is 75.93 degrees, and in radians 1.325. Okay. We can also use the inverse trig functions and a calculator to help us solve triangles with non-standard angles. Just like example number 4 here, solve for the angle theta in the triangle below. So we have here the angle, the theta, and the two sides 12 and 9. If this is the angle and these two sides here, this is the adjacent side and this is the hypotenuse. And adjacent and hypotenuse, remember, are SOHCAHTOA, so we're using cosine because we know that cosine theta is adjacent over hypotenuse, and let's use that here, which is equal to 9 over 12. And then since we want to solve for theta, so we just get inverse cosine of 9/12, and again just use a graphing calculator or your decimals, just type inverse cosine of 9/12 and you will get in degrees 41.41 is the answer. Okay, let's try a quick check number 2 here. Given the theta, we have this side and these two sides, 6 and 10. 6 is the opposite side and this is the hypotenuse, and opposite the hypotenuse for SOHCAHTOA we need to use sine. So sine theta is equal to opposite over hypotenuse, so 6 over 10, and we can solve for our theta, that is inverse sine of 6 over 10. Use your calculator, and that is approximately in degrees equal to 36.87 degrees. Next, evaluating compositions of trig functions and their inverses. We have a question here: is the following statement correct? Inverse sine of 5 pi over 4, is that equal to 5 pi over 4? So that's the question now. So 5 pi over 4 is equal to 5 pi over 4, but we can say that 5 pi over 4 is outside of the domain of sine and inverse sine. Just to recall, for inverse sine, that is from negative pi over 2 to pi over 2, and that is only from that quadrants 1 and 4. And cosine, that's from 0 to pi, which are the quadrants 1 and 2. And for tangent, from negative pi over 2 to pi over 2, again, those are quadrants 1 and 4. And again, 5 pi over 4 is outside the domain of sine and inverse sine. So again, we see that sometimes we'll have to restrict the domain. So I'm going to show you some examples here. Example number 5, evaluate the following. Be sure to give answers in the correct and restricted domain. So letter A, inverse sine of sine pi over 3 is, do that, is equal to pi over 3. And inverse sine, that's from negative pi over 2 to pi over 2, and you know that pi over 3 is here. This is pi over 3. That's in quadrant 1. So this is the answer for letter A. B, inverse sine of sine 2 pi over 3. And that is equal to 2 pi over 3, but it's not in quadrant 1. So coterminal of 2 pi over 3 is actually pi over 3. Next, inverse cosine of 2 pi over 3. So just showing you where 2 pi over 3 is. Also for letter B, we know that this is 2 pi over 3 because the coordinates here are negative 1/2 and square root of 3 over 2. And for cosine, that is from 0 to 2 pi. So that is actually the answer, 2 pi over 3. Then letter D, inverse cosine of negative pi over 3. Where is negative pi over 3? This is negative pi over 3. But a cosine is only from, the domain is from 0 to pi. So coterminal of that is pi over 3. So the answer is pi over 3. So finally, we can use right triangles to help us solve mismatched compositions in the following example. Example 6, use the right triangle to find an exact value of sine of inverse cosine of 4/5. So use the right triangle to find the exact value, again, of this sine inverse cosine of 4/5. And for cosine, we know that with SOHCAHTOA, this is adjacent and this is hypotenuse. So if we have our right triangle, this is the angle, adjacent is 4, so 4 here, and hypotenuse is 5. Then we can solve for the missing angle. So remember the Pythagorean theorem, a squared plus b squared is equal to c squared. So let's say we have 4 squared plus b squared is equal to 5 squared. B squared is 5 squared minus 4 squared. B is the square root of 25 minus 16, and b is square root of 25 minus 16 is 9, and square root of 9 is equal to 3. So that side is equal to 3, which is the opposite side. So now we can solve for sine theta. So this is like sine theta, and we know that sine theta is with using our right triangle here, SOHCAHTOA is opposite over adjacent, opposite over hypotenuse, and opposite is 3 and hypotenuse is 5. So the answer is 3 over 5. Letter B. Use the right triangle to find the exact value of sine inverse tangent of 7 over 4. So tangent, what do we know about tangent for SOHCAHTOA? So this is the opposite side and 4 is the adjacent side. So let's use another right triangle here, and if this is our angle, opposite is 7 and adjacent is 4. And using Pythagorean theorem, we can solve for the hypotenuse. So that is 4 squared plus 7 squared is equal to c squared. 16 plus 49 is equal to c squared. 16 plus 49 is 65, and the square root of both sides, square root of 65 is your hypotenuse. So this is square root of 65. So now we want sine theta, again, is opposite over hypotenuse, and that is gonna be this is opposite, this is your hypotenuse, this is adjacent. So theta is opposite over hypotenuse is 7 over square root of 65, and we can rationalize this denominator by multiplying by square root of 65 over square root of 65, and that is equal to, multiply across, so 7 square root of 65 over square root of 65 times square root of 65 is 65. So that is the answer. Okay, let's use some lecture questions here. Why must the domain of sine x be restricted to negative pi over 2 to pi over 2 for inverse sine of x to exist? And simple answer for that is to be 1 to 1. Even though y equals cosine x and y equals inverse of cosine x are inverses, y is inverse cosine of negative pi over 6 is not equal to pi over 6. Why not? So remember that the domain of inverse cosine is from 0 to pi only, and negative pi over 6 is not within 0 to pi. So negative pi over 6 is out of bounds. Okay, so is the number 3. For the following exercises, evaluate the expressions. Inverse sine of square root of 2 over 2. So square root of 2 over 2, yes, that is pi over 4. And then inverse tangent of negative 1. And remember, tangent is going to be from negative pi over 2 to pi over 2. So just to recall, using a unit circle, to get a negative 1, you will have the angle here, because this is negative, this is square root of 2 over 2, and negative square root of 2 over 2. When you divide this is negative 1. This is 7 pi over 4, and 7 pi over 4 is not between negative square root of 2 over and square root of 2 over 2. So get the coterminal of that, or just use this angle, which is, yes, negative pi over 4. Number 4, find the exact value of cosine of inverse sine of 1/2 without using a calculator. Inverse sine of 1/2 is, that is within, you know that 1/2 is within the unit circle, and this is equal to pi over 6. So meaning we can get now cosine of pi over 6. And cosine of pi over 6 is square root of 3 over 2. Okay. Last problem. A 20-foot ladder leans up against the side of building so that the foot of the ladder is 10 feet from the base of the building. A safety specifications call the ladder's angle of elevation to be between 35 and 45 degrees. The question is the ladder following the safety specs? So again, this is the 20-foot ladder that leans up against this side of this building, and it is 10 feet from the base of the building. So we have here 10 feet. So this is our angle. We have these two sides here. We have adjacent and hypotenuse, right? So this is the adjacent side and this is the hypotenuse. So we're using SOHCAHTOA. We're going to use cosine. So that is cosine theta is equal to adjacent over hypotenuse is 10 over 20, and if you want to get the angle, that is inverse cosine of 10 over 20, and what is inverse cosine of 10 over 20, which is equal to 60. You can use a calculator. Inverse cosine of 10 over 20 is 60 degrees. And to recall the safety specifications, that it should be between 35 and 40 degrees. And 60 degrees is not between 35 and 45 degrees, rather. So we can say that, yes, it is not safe. Okay, so that's it for this section, section 6.3. Let me know if you have any questions, and thank you.